So in this class, I want us to consider working or calculating of the gradient. Remember, a straight line is something that you actually need to work with one or two things from the gradient, the equation, the drawing, the sketching of the straight line, like we had in the previous classes. So what is it that we are talking about here on the gradient? Remember, if you are to consider a straight line, this is from our Cartesian plan, which is the graph that you are going to have later on. You have got a straight line. The lines of this nature and the lines which are drawn going this side like this. Look the way that I'm having these lines this way. These lines, they have a different gradient with these lines. The gradient, remember, that's the steepness of the slope, the slope. So the slope of this is increasingly going up. This one is going down. That's a negative slope. So what is the concept now of calculating this gradient given points which are on the graph, which are on the line? You have got 2 points. So it follows that from this steepness or the formula, we can calculate the gradient. Instead investigating to say a line is like this, so it's going to be having a positive gradient. Just calculate your gradient and see if it is positive or not. All right. So to determine the gradient, you are going to need 2 points. So given 2 points, that is the case. Given 2 points, let's say we have got 2 points that we are given, and these 2 points, I'm going to name them x1, y1 like this. Remember, a point is just supposed to be xy. So this is to denote or to mark to say this is the first point, x1, y1, and the second point, x2, y2 like this. It's just to denote the second point. So it's just going to be x2, y2 like that. So let's say these 2 points we are given that this is our point and this is our second point. It follows that our gradient m being the change that is going to happen in y over the change in x. So it's simply the change in y over the change that is going to happen in x. So the change in y can be an increase, a decrease. The change in x can be an increase, a decrease. So we can just use this as a formula. Y changed. Remember, it's a change. Y changed from y1 to y2. So how do you find the change? Final minus initial. So it is going to be y2 minus y1 like this over x changed from x1 to x2. So it's going to be the difference, x2 minus x1. So this is the formula that we can use for gradient. So take note, this m represents gradient in our mathematics when dealing or working with the straight lines. Wherever you see this m, it is for the gradient. We are going to talk about the equation of a line. We're using the same m, this one. So I want you to just know it right now so that you do not have confusion as we are going to be moving in with our revisions. Wherever we have m under straight lines, it represents the gradient. So that's the formula that you're going to have. So take note, because we are subtracting the y and also subtracting the x values, it also follows that even if you use this as y1 minus y2 over x1 minus x2, as long as you start with the 1, y1 minus y2, 1, okay? Here you started with 2, so it's 2 minus 1, 2 minus, you must have same part, 2 there. This is a 1. Do not mix to say this is y2 minus y1, then here you write x2 minus x1. No, do not mix. So also just work with one formula that you understand. If you understand the letter formula, use it. If you understand this one, work with it. So that's the concept. Using the points, you can calculate the gradient. So I want you to see something. Let's say you're given a point. You have given 2 points. Given 2 points, 2 and 3. And another point is 0, 5, like this. These are 2 points that we are given. and we want to calculate the gradient. So in order for us to have our gradient, which is m from our formula, we need to use y2 minus y1, the change in y over the change in x, where we can name our points. This is x1, y1, x2, y2. So you can substitute the points, the values that you're given, y2, the y value, that is a y2, which is 5, minus y1, which is a 3. You substitute the y1 value, that's a 3, over x2, that's a 0 there in place of x, minus x1, which is a 2 like this. So you can simplify. That's having the gradient. 5 minus 3, that is a 2 over 0 minus 2, which is minus 2, and that is going to give us a minus 1, or you can just use your calculator at this stage to simplify that. So that is, you can have the gradient using points. You can calculate the gradient. So I want you to see here, I'm going to talk about another way, if it permits, as we are going to move on. If you check the first part that we are given on C, you have the points. Remember, we need to determine the gradient in this case. All right, so let's start with this one, C. There is a point that is presented here. We can use the movement, but we can use the points direct. What is this point indicating? Where does this point lies? It lies in the y-axis. Remember, in the y-axis, I said x is equal to what? X is equal to 0. Does not change that part. So meaning to say we have a point, this one, where x is what? Where x is a 0, y is a 4. And another point that is directly given, this one, 2, minus 2. So that's it. So we can calculate our gradient, which is m. So you can write gradient, or you can write it as m. So remember the concept, x1, y1, x2, y2. So let's substitute there. y2 minus y1. Our formula is not going to change. x2 minus x1. So y2, that's a minus 2, minus y1. y1, that's a 4. Value of y here, that's a 4, over x2, which is a 2 there. So this is our x2, which is a 2. Minus x1, that's a 0 there. So you can just use your calculator straight, or you can simplify minus 2 minus 4, that is a minus 6, over 2 minus 0, which is a 2, then divide. That was going to be a minus 3, just like that. From the points that you are given, you have got the gradient. Same concept on D. You have got the point that you have, that you're given, minus 1/6. It's a point. Minus 1/6. And another point that you're given, the 4, there's the y-intercept. Like I said, x is equal to what? X is equal to 0 in the y-x. So that's 0, 4. Remember the point, x versus y. So x, you start with x. X is 0 there. Then it is the y value that you're given, 4. So just like the previous case, we can have our gradient. So you can write this as m. You can write it as gradient. It's up to you. So as you saw from our formula, we're going to have y2 minus y1. So that's y2, which is 4, minus y1, that's a 6, over x2, that's a 0 there, minus x1, that's a minus 1. So take note, that's 0 minus 1. The minus, this one, it's the formula. It's on the formula, this one. It's on the formula. But the x that it's carrying, the one that you're substituting, it's carrying a negative. So do not neglect the minus of the formula because x is having a negative. That's its own negative. The formula is its own negative. The x has got its own negative. So do not confuse between the minus of the formula and the minus of the x. But knowing that a minus and a minus, guys, that's a plus. So like I said, guys, you can use your calculator at this stage. You can just simplify 4 minus 6. That's minus 2 over 0 plus 1, which is a 1. So m, being the gradient, is going to be equal to minus 2 of this line. So that's the same part that you're going to use throughout having these two lines. So when you're given lines of this nature where they are actually clear like this, you can even do like that by movement. The change in y over the change in x. Y is going down, that's a -4. To the right x, that's a +4. So m, the change in y, -4 over the change in x, which is a 4, you're going to get a -1. So I want you to use points here and see you're going to have the same thing. Remember, in the y-axis, x is equal to 0. So this point here is given as what? As 0, 4. And this point in the x-axis, remember, in the x-axis, y is equal to 0. So we are given the x value, which is 4, but the y value is what? The y value is a 0. So I want you to use these 2 points, calculate your gradient, and prove it if it is going to give you a -1. On the other hand, even this part by movement, you can even move the increase. Y is going up and x is going to the negative. So going up, that means that's a +2. Going to the left, that's a negative. So our m being the change in y, which is 2, over the change in x going this side, which is a -8, was going to give us, if you divide on your calculator, that's -1/4. All right, -1/4. So I want you to prove that the gradient there is -1/4 using the points that you can see here. This point in the x-axis, -8. So that's -8 what? -8, 0. Remember, y is equal to 0. And also, this point that we are given in the y-axis, the y-axis where x is equal to 0, this point of -2. So that's 0, -2, like this. All right. So I want you to use these 2 points, calculate your gradient. You must obtain the same answer of what? -1/4 using the formula, which is using the change in y over the change in x, y2 minus y1 over x2 minus x1, just like how we're using this formula on these other points. So I want you to prove that with the formula and see if you are going to obtain same answer also on G. Try it and see if you're going to obtain same answer of -1. So these are the typical questions on your gradient. We shall continue finding of the equation of a straight line and so on. Just working also with typical exam questions so that you understand the concept of these questions that you shall be having in your exams.